Hello, physics said question number 11. This is a very interesting question. Question says that the average electric charge transported in a lightning strike is 20 coulomb, and the energy converted as a result of this action is 2.4 in 10 power 10 joule. Question: what is the potential difference V between the cloud and the ground? Cloud is positive, ground is negatively charged, so there will be a potential difference established. So V is equal to E. E is electric field over Q. Q is a charge. So this is E is energy over Q. Q is a charge. So 2.4 in 10 power 10 joule divided by 20 coulomb, which is equal to the potential difference is 1.2 10 power 9 volt. This is huge. So question number 2, the air breaks down and become a conductor at the voltage exceeding 10 power 1 into 10 power 4. So 1 into 10 power 4, but here is a 10 power 9. So 1 into 10 power 4 air become a conductor. What would be the maximum height of the charged thundercloud above the ground so that the lightning strike can take place? So what should be the distance, the height for which the air become conductor? So the breakdown voltage it is 1.0 in 10 power 4 volt per centimeter is equal to uh, per centimeter is 1.0 in 10 power 6 volt per meter. So volt per meter. So I think this is a centimeter. Volt per centimeter. So that's 1.0 in 10 power 6 volt per meter is equal to, so, and we have this voltage 1.2 in 10 powers 9 over h. So h is equal to, from this one we can calculate, which is h height is equal to 1.2 kilometer. At the height of the 1.2 kilometer, in such situation, the atmosphere, the air become conductor. Next question is that the typical thunderstorm lightning flashes strike the ground at an interval of 2 minutes. Over the whole surface of the earth, the total current between the atmosphere and the ground average is 1200 ampere. Calculate the average number of thunderstorms taking place at any instant over the whole earth. So that is a very interesting question. So the typical thunderstorm lightning flashes the ground at the interval of 2 minutes. So Q is we have to find the number of thunderstorms happening all over the earth at one instant. So you can find out that the total charge, how much is the total charge? Charge is equal to current into time. Current is 1200 ampere, and time is a 22 minute. 2 minute is this one in 2 minute duration. So the total charge is 1.44 in 10 power 5 coulomb. So number of thunderstorms is equal to one, the total charge divided by 20 20 coulomb. So the 20 coulomb, so that will mean it is a 7.2 in 10 power 3 uh, number of thunderstorms as per 20 coulomb per lightning. So 7,200 thunderstorms are happening at any instant all over the world. Next question is that in order to determine whether the lightning contribute to the warming of the atmosphere, calculate the average heating power in a cubic meter of air due to these thunderstorms. these strikes, these strikes, if they all occur in the lowest 1 kilometer of the atmosphere. So the radius is 6370 kilometer, 637 kilometer. And thunderstorms. So from thunderstorms is lightning. Lightning is a heating of the atmosphere because there is a power and there is a heating, and heating is the warming of the atmosphere. So if there are so many thunderstorms happening every time, 7,000, more than 7,000 thunderstorms at a one given time all over the world. So if they are at the 1 kilometer atmosphere height, so what will be the heating of the atmosphere? So thunderstorms strike 1 kilometer height. So that will generate the energy which is equal to 2.4 in 10 to the power 10, which is we have already this one, 2.4 in 10 power 10, 2.4 10 power 10 joule. In 2 minutes, the power will be energy over time. So that will be 2.4 in 10 power 10 joule divided by 2 minutes. 2 minutes is 120 seconds. So the power will be 2.82 into 10 power 8 watt. So, but there are 7,200 thunderstorms. So the power, total power, so this is one. So 7,200 multiplied by this power, that will be 1.44 in 10 power 12 watts. So this is the power will be distributed all over the atmosphere. So volume of the atmosphere will be uh, the surface area of the Earth, which is a 4 pi r square, multiplied by 1 kilometer height, which is 1,000 meter, and that will be in meter cube. So that if you calculate using this uh, radius, radius of the Earth, which is three thousand 6,370, or sometime we take 6,400 kilometer. So if you take this one as 6,370 kilometer, and then volume will be 1.6 to 10 power 17 meter cube, and the power divided by the volume, so that will be 2.8 microwatt. That will be, or 3 microwatt. That will be very small. That will be not a contributing factor in the heating of the atmosphere because of the thunderstorm and striking lightning.